Find the volume of the solid when the region bounded by y is equal to x to the 1/2 power, y equals 2, and x equals 0 is rotated about the line x is equal to 4. Well, these functions that we have here are pretty easy to graph, so let's actually do that. X to the 1/2 is also known as the square root function. So its values are 0, 0, 1, 1, 4, 2. And then we have y equals 2. That's another section of our graph or thing that our graph is bounded by. And x equals 0, or the y-axis, is the last one. So the section that we are going to revolve is right here. And we're going to rotate it or revolve it about the line x equals 4. So this is going to be the line that we're going to revolve our solid around. When we do that, it's going to look something like this. You can see how the green section over here is then reflected across, and we have our circles in between there. So because we're rotating our section of the graph about a vertical line, we have to make sure that our equations are written in terms of y. Well, this first one is not. So let's actually work on converting y is equal to x to the 1/2, like solve it for x to put it in terms of y. And to do that, we'll square both sides. So we'll get that x is equal to y squared. If we look at our graph, we can see that the bounds with regards to y will be from 0 all the way up to 2. So y equals 0 and y equals 2 will be our bounds for integration. So we're going to have that the volume is equal to pi times the integral from 0 to 2. And now we have to determine what our outer radius is and our inner radius. Well, we can clearly see the outer radius is this part from x equals 0 to x equals 4, or that distance. Now you can either write it in terms of like as a subtraction expression as 0 minus 4, or since you know that this distance has to be positive, and we're going to square it anyway, you could say that capital R of y is going to be 4. So you could either use 0 minus 4 and square it, or you could just do 4 squared. They will both give you the same answer here, mainly because we are squaring. And then we're subtracting the inner radius, or little r of y, is x is equal to y squared, and it's shifted 4 units to the right, which is minus 4. So you're going to have y squared minus 4 as that little r of y. So we have y squared minus 4 squared. And when we integrate, we're going to integrate with respect to y. So that's going to reduce to pi times the integral from 0 to 2 of 16 minus y to the 4th minus 8y squared plus 16 dy. And when we distribute that negative through, we'll have pi times the integral from 0 to 2 of 16 minus y to the 4th plus 8y squared minus 16 dy. Notice that the 16 in front and the minus 16 in the back, they cancel each other out or add up to 0. So we're going to have pi times the integral from 0 to 2 of negative y to the fourth plus 8y squared. And we're integrating with respect to y. So we still have pi out in front, and now we can integrate. Negative y to the fourth is going to be negative y to the fifth over 5 plus 8y squared integrates to become 8y to the third over 3. When we evaluate this from 0 to 2, we'll end up getting pi times negative 32 over 5 plus 64 over 3. And then we would subtract from that. If we substitute 0 in there, we're going to get 0 for both of them. So that's going to be pi times negative 96 over 15 plus 320 over 15, which is equal to 224 pi over 15, or answer choice A.